Welcome back to the, project channel. We got a personal project for once. This is an LED chaser I built. I'm gonna walk through, the components, and we'll do a quick demonstration with this battery. So, here we have an NE555 timer IC. We have a 4017 decade counter. We got 10K resistor. We have 4 120 ohm resistors. We have just 4 LEDs, they're bright white. We have a 10K potentiometer. We have a 10 microfarad dielectric capacitor, just electrolytic capacitor. It's polarized. And yeah, I think that's all the components we need. We have our battery, 9 volts. I'll quickly go over how this works. So the 9 volts in the ground will be connected to plus and minus, and they'll supply power, they'll supply ground to everything. And the key way that it works is that this is going to receive power, and based on the resistance, which is controlled by this capacitor, this resistor, the 10K ohm, and this potentiometer, which we can dial to change the resistance. Based on that resistance, it's going to control the frequency of a clock. Now, its clock is the output. The output is basically like a clock. It's going to be a square, high, low, based on a duty cycle. This one has about like a 70% duty cycle around 70% duty cycle. And changing the resistance will increase or decrease the frequency of that wave, that square wave. And that is connected to the clock input of this decade counter. Now, how the decade counter works is for every increment, or every time the clock goes up on the rising edge of the clock, it goes next in the counter. It'll go 1, 2, 3, 4 until 10. And the way I've wired it, we basically have like 2 sets of LEDs. We have like group 1 and group 2. So I only need 2 outputs. So I've done output 1, output 2, and then the third output, or I guess the second output, because there's 0, 1, 2, is connected to the reset pin. So once the decade counter reaches this output 2, or the third output it has, it's going to reset it, so it'll go back to 1. So instead of going 1, 2, 3, 4, 5, 6, 7, it'll go 1, 2, reset, 1, 2, reset. And that'll ensure that the LED chaser works as intended. Now, these are just current limiting resistors to make sure that the LEDs don't burn out and don't die. And with all that, that's the quick rundown on how it works. And we can start looking at if it works. Same video, obviously. We can now go on to seeing if the design works. So I'll connect the ground of the battery to the negative power rail, and the power, it should be 9 volts, to the positive rail. Right. You can see this is kind of threaded. If I put it against my finger, you can see. So you have to twist it a bit to get it proper. And you can see this is, I guess these two together are one system. These two together are the other system, which I'm sure you've seen on the schematic if you're following the website. And they alternate because the decade counter only counts 1, 2, and 1, 2, 1, 2, 1, 2. It just goes on forever. And let's see if our potentiometer works. Can we adjust the speed? Oh, we can definitely adjust the speed. Changing this changes the resistance. This potentiometer serves as a variable resistor. So it changes the resistance going into pins 2 and 6 of the timer, which changes the output. It changes the frequency of that square output we looked at earlier. And you can see the proof of concept.